Yeah, good day. I hope you are good. Let us tackle these three questions here. So the question was solve for x, which means we have to find the unknown x. So I want us to start with 1.1.1. We have x into x plus 1 equals to 6. When we have something like this, we distribute our x and then we simplify. Let us start by distributing our x. X times x, it is x squared. X times 1 is going to give us positive x, which will equals to 6. We are going to take our 6 to the other side. Taking our 6 to the other side, we have x squared plus x minus 6, which will equal to 0. From here, we can then solve for x by using our quadratic formula, or we can complete the square, or we can just factorize. From here, we're going to use the simple method. I advise using the simple method. That means the straightforward method. The one that is not complex and complicated is the one that we are supposed to use here. So checking our equation, we can see that we can factor out our equation. X squared plus x minus 6 equals to 0. So if we use the factor of 3 and 2, we will be able to factorize this equation. We have x, we have 3, we have 2 equals to 0. From here, we now know that we need to have a positive x. For us to have positive x, it is supposed to be positive 3 and negative 2. So this is going to give us a positive x. So that means we have positive here, we have negative here. From here, now we can say that x plus 3 will equal to 0, or x minus 2 will equal to 0. That is to say, x will equals to negative 3, or x will equals to 2. We can do the same with our quadratic formula. Our quadratic formula is in this manner. X equals to negative b plus minus the discriminant over 2a, which is basically negative b plus minus b squared minus 4ac over 2a. So checking our equation, we had x squared plus x minus 6 equals to 0. We now know that our a will equals to the coefficient of x squared, which is 1. Our b will equals to 1 also, the coefficient of our x. And then our c will then be negative 6. From that, we substitute to our equation. X will equals to negative into our b, 1 plus minus square root of our 1 squared minus 4a, which is 1, c, which is negative 6. From here, we divide by our 2a. Our a is 1, So that means we can have something like this. From here we use our calculator. We then simplify. -1 times 1, which is -1, plus minus 1 squared it's going to be 1 squared into, let us write it here, 1 squared, which is 1, -4 times -6, which is going to give us 24. From here we know that it is supposed to be plus 24 over 2. Then x will then equals to -1 plus 24 is square root of 25, which is 5, plus 5 over 2, or x will be -1 square root of 25, which is 5, and then we get our answer. That is to say, we have x will equals to 4 over 2, or x will equals to -6 over 2, which will then be -3. This is also what we can say is true. So in other words, we have the same answers even though we used different methods. So the common mistake that you can make is if you say x equals to 6 or x plus 1 equals to 6. This is wrong. It is going to give you a wrong answer if you use that approach. So you can only use that approach if you have something that equal to 0 on the other side. So that is to say, x will equal to 0 or x plus 1 will equal to 0. X will then equal to -1. If there is a 0 on your right hand side, you can do that. But if there is no 0 on the right hand side, use one of these approaches. That is what our first question wanted. Let us go see the second question. So the second question said, I'm going to call it 1.1.2. We have 3x squared minus 4x equals to 8. The first thing we do is to make sure that our right hand side equate to 0. So that is to say, we take our 8 to the other side, which is going to change the side. We have 3x squared minus 4x minus 8 equals to 0. So checking our equation, let us go back to the equation. It didn't specify which method to use. That means we can use any method, but I advise you to use simple method. So from here, let us use the quadratic formula. Which is x, which will equals to -b plus minus that is discriminant over 2a, which is negative b plus minus b squared minus 4a c over 2a. From here, let us now find our a, b, and c. So our a is 3, our b is negative 4, and our c is negative 8. From this, we then substitute our equation. We have x equals to negative b plus minus the discriminant over 2a, which is negative, the b you have is negative 4 plus minus b squared, which is negative 4 squared minus 4, a which was 3, let us put our 3 there, c was negative 8 over 2a, which is 3. Then we simplify. From here, we're going to get negative 1 times negative 4, which is 4. Let me write it properly. X will be this part, which is 4 plus minus the part under the square root. When we use our calculator, we are getting negative 4 squared, which is 16, plus negative 4 times 3 times negative 8. It is going to be plus 96 over 6. From here, you can simplify 16 plus 96, which is 112. That means it is 4 plus minus square root of 112 over 6. From here, I see that I can simplify this. So I'm going to get 4, let me write it this way, 4 over 6 plus minus square root of 12, 112 over 6. This part will be 2 over 3 plus minus square root of 112 over 6 would be 2 square root 7 over 3. I use the calculator to get this part, or we can just use the calculator from this part here. And then we're going to get what? From here we're going to get 2 plus minus 2 square root 7 over 3. And then if you are required to write it in maybe 2 decimal form, make sure you round off the final answer only. So let's say they said round to 2 decimal places. That means we are supposed to have something like x will equals to 2 plus 2 square root 7 over 3, or x will equals to 2 minus 2 square root 7 over 3. Round this to 2 decimal places, 2 plus 2 square root 7 over 3, which is giving me 2.4305 carrying on, but I have to round to 2 decimal places. That means I have 2.43. We round the last number. So in other words, you can just not write this and write the final answer. From here, we're doing the same thing to our 2 minus 2 square root 7 divided by 3. We now have something like negative 1.097 carrying on, and then that is to say for 2 decimal places we have negative 1.10. That is to say we can just remove this and write this as our answer. So that is what 1.1.2 required. Let us tackle the last question. So the last question was given as an inequality. It has got an inequality sign. So we have, let me call it 1.1.3. We have x squared plus 1, which is greater or equal to 5x. We know that immediately when we have something to the power 2 as an inequality, we can use the critical value method. We can call it CV method. Let us do that here. We're going to use our CV to get our roots, and then we return our sign, our inequality sign after getting our roots. We are going to equate this equation with an equal sign. After doing so, we get our roots. From our roots, we then remove our equal sign back to our inequality sign. From there, we check where the condition is holding. We're going to do that. Let me now do that as a mathematical approach. So the first thing that we can do is to take this one to the other side. That means we have 4x squared minus 5x plus 1 greater or equal to 0. From here, I'm going to say CV method, which is critical value method. Now we have 4x squared minus 5x plus 1. We equate it to 0. From here, it's either I use my quadratic formula, I complete my square, or I factorize. Checking my equation, it is easier to spot that I can factorize, but I advise you to use the simple method, the method you are comfortable with. Any of the method you use, you're still going to get the same answer. For my case, I'm going to try factorizing. So I can then see that we have 4x and we have x. For us to get a negative, I need -1 and -1. So that is to say we have -1 this side, -1 this side. So from here, that is to say 4x minus 1 will equal to 0, or x minus 1 will equal to 0. That is to say, x will then equal to what? 1 over 4, or x will equal to 1. From here, we used the CV method to get the roots. We're going to draw our number line, and then we have the value. This is 1 over 4, and then this is 1. So from this, we know that the condition said greater or equals to. That means we need to shade our circles. They are also included. That's the first thing we can do. And then we know that 1 over 4, if we write it in a decimal form, we have something like 0.25. 1 over 4 is 0.25. Let me write it somewhere here. 0.25. So we know that 1 over 4 is the same as 0.25. We are going to, now we have an equation in this manner, which is 4x squared minus 5x plus 1 is greater or equals to 0. We're going to use a value from this side, which means the value that is less than 1 or 1 over 4, to see if this condition will give us what? Will give us a value that is less than or greater than 0, less than or equals to 0. I mean, or the value that will be greater or equals to 0, or will the value be less than or equals to 0. So that's what we're going to confirm. We're also going to do the same with the value between 1 over 4 and 1. We're also going to do the same with the value that is greater than 1. So let us start with the value that is less than 1 over 4. We know that this is 0.25. We can just use 0.2. So let us use 0.2 to confirm, which means we can use 1 over 5 this side. So substituting our 1 over 5, we have 4 1 over 5 squared minus 5, 1 over 5 plus 1. Then we try to check the sign. That's the main thing we are more concerned about. 4 into 1 over 5 squared minus 5 into 1 over 5 plus 1. We're going to get a positive number. The value that we get is a positive number, that is 4 over 25. So this is to say, on this side, we now know that there will be positive values. So this is to say the condition is still holding. The condition is still holding. We now confirm the value between 1 over 4 and 1. We can just use 0. Substituting our 0 here, one of the condition will be correct. And then let us substitute maybe 0.3 and see what is going to happen. We have 4 into 0.3 squared minus 5 into 0.3 plus 1. So it holds for only 0 because 0 the equal sign set greater or equals to 0. But for now, if we use maybe 0.3, we're getting a negative value. So that is to say, in between we can deduce that the values will be negatives. And then if we use the value that is greater than 1, we are supposed to have positives. We can use 2 on our equation and confirm. 4 into 2 squared minus 5 into 2 squared plus 1. We are having a value of 7, which is positive. So that is to say, we have something like this. We know that we have this number line here. We have 1/4, and then we have 1. We said this is included and this is included. From here we have the negatives. It only holds for the 0 part, but since most of them are negative, we are going to deduce that all the values are negatives on this side for that condition to be met. And then we have positives on this side, and then we have positives on this side. Or we can just use the arrow and draw. And then we know that from this side we have negative infinity, and this side we have positive infinity. From here we conclude our condition by saying that the inequality will hold for negative infinity to 1/4 included, union 1 included, to positive infinity. In simple terms, this is to say x will be less than or equals to 1/4, and x will be greater or equals to 1. So I hope you got the idea on how to approach these questions. See you on the next session.